Video of higher level maths paper 1. So today I'm going to go over basic algebra that hopefully will be covered from Leaving Cert, but this is just a recap over it. This sort of stuff is extremely important, so when you're going over your notes, I'd highly recommend to get algebra is the most important thing, no matter what you go into. Algebra is used if there's any bit of maths in it. So once you get a handle of the algebra, everything comes really easy. It's kind of like a language, if you understand the grammar and how to form sentences, then speaking it is quite easy. But if you don't understand that, then you can learn all the words you want. You can learn off the dictionary. It's not going to be great. So the next, I'm not sure how many chapters of algebra there is, but the next of these videos are extremely important. So it is worthwhile, just studying this and making sure you have a good grasp of it before you go on further. Without further ado, I suppose we can start. So the first thing is just kind of multiplying out brackets and stuff. Okay, so how do you multiply out brackets? So for example, if we have something like 4 into 2a minus b into a minus 5b. Okay, so whenever you have something like a, b, this means a multiplied by b. Okay, so here what we're actually saying, we're saying 4 multiplied by 2a minus b multiplied by a minus 5b. Okay, that's what the statement above says. And now another thing that you need to realize is just, or remember, I suppose, recall, whatever you want to call it, is your BIMDAS or BOMDAS, whatever it is. So I use BIMDAS. MDAS. So this basically says you always do brackets first, then you do indices. Okay, then you do multiplication, and division. So multiplication and division. So when everything, I'll just finish, and then A and S is just adding and minusing. Okay, so you have 4 separate levels. So what it means is that brackets coming first means that if you see 2 brackets, you always do them first. Okay, that's what that means. All right, so you do what's in the brackets. So you don't do the brackets first. So it's not a case of here the way we have 4 multiplied by a bracket and say, oh well, there's a bracket, so we'll do that first. No, what the brackets mean, you do what's inside the brackets first. That's all the brackets mean. Okay, then your next one is indices. That's just powers. Okay, so I might just write that beside it because people mightn't be familiar with that. So it's just powers. If you had squared, cubed, you do that first before you do multiplication and division. Multiplication and division are on the same line. What does that mean? That means whenever both are present, you work from left to right. Okay, so if you have a line and you have multiplication and division, and you're sitting there and you're like, oh, what do I do first? You just work from left to right. Okay, and then the next line, the final line, is adding and minusing. That's the last thing you do, and then that's, again, you just work from left to right. So if minusing is first and then adding, you minus first and then you add, or vice versa. Them being on the same line just means that you can just work from left to right. Okay, so Now, what I want to do with this one is, because I'm multiplying into the bracket, how do I multiply into a bracket? First of all, I need to multiply 4 by the first number, and then I need to multiply 4 by the second number. So again, you've multiplication here twice, so I'm just going to work from left to right, okay? So I'm going to do 4 multiplied by 2a first to get 8a. 4 multiplied by minus b is minus 4b. Alright? And that's multiplied by a minus 5b. Okay, I might just move this down, just to have a bit more room. So now that I have this, now for this one, what I'm going to do is, sorry, there we go, okay. So now, how do you multiply out brackets like this? You do the exact same thing that we just did, okay? Because a lot of people kind of get fuzzy with this. Just think, if it was a simple case, what would I do? So a second ago, we just had one number, and it was nice and easy. You multiply the first number by the first number, and then multiply the first number by the second number. So I'm going to do the exact same thing with the 8a. So your 8a is your first number. I'm going to multiply that by the first number, and then I'm going to multiply it by the second number. Alright? And now also, just to get a different color, I'm also going to do the same thing now here. Okay? So hopefully that should make sense. That you sit there and you say, well, before I had one number, I multiplied the number by the first term, and then I multiplied by the second term, and I got what I got. And now but there's two numbers, so I can just do the exact same thing. So I'm going to multiply the 8a by the a, and then the minus 5b, and then I'm going to multiply the minus 4b multiplied by the a and multiplied by the minus 5b. Okay? So now if I do 8a multiplied by a, I get 8a squared. If I do 8a multiplied by minus 5b, so 8 by minus 5 is minus 40. A multiplied by b is just ab. Minus 4b multiplied by a is just minus 4ab. Minus by minus is plus. Okay, so just remember that. 4 multiplied by 5 is 20. B by b is b squared. And now these two terms, they both have an a and b common, so I can add them. So this whole thing is going to be 8a squared minus 44ab plus 20b squared. And then that's the final answer. Okay? So that's how you do that. So you just multiply them out. Alright? And that's how you multiply them out. Now another thing could be something like if we had 23x minus x into 2x plus 3 squared. Okay, now we're going to have to look at our BIMDAS again and say, okay, we have brackets, so we do them first. Now, the thing is, I can't add 2x to 3 because I don't know what x is. So I know that I said you have to do them first, but in this case, I can't do anything with it, you know. It's not like I can say 2x plus 3 is equal to 7, because I don't know what x is, and therefore I can't give it a definite answer. So what's in the brackets is just 2x plus 3, and that's that. Now, indices. The indices is this guy here. That's an indice, because it's a power. So whenever you have a power. So now, that's what I'm going to do. So my next step is going to be to resolving this thing. So I need to figure out what is 2x plus 3 all to be squared. And again, you might look at that and say, I have no idea how to get that. Just write it out. What does it mean for a number to be squared? This is the same thing as 2x plus 3 multiplied by 2x plus 3. Okay, that's all it is. And if that was to the power of 7, I just have 7 of these, you know? So it's just going back to your definitions. What does it mean to square a number? You multiply the number by itself. Okay, grand. So 2x plus 3 squared is just 2x plus 3 multiplied by 2x plus 3. And again, we have the exact same thing that we had above. So above here, we said that if we have a bracket, multiply another bracket, we get this thing. So this is going to be no different. I'm going to multiply that by that. I'm going to multiply that by that. I'm going to multiply this by this. And I'm going to multiply this by this. Okay? So 2 times 2 is 4. X times x is x squared. 2x times 3 is plus 6x. 3 times 2x is plus 6x. And then 3 times 3 is plus 9. Alright? And then this is just going to be 4x squared plus 12x plus 9. Because again, you have that 6x plus 6x, because those two things have an x in common. You have the same number of x's, and therefore you can just add them. Okay? The same way that I can add x and x, I can add x squared and x squared, I can add 1 and 2, because they had the same number of x's, and therefore I can just do this. Okay, now I can plug that back into the original expression. So originally, what we had is, we had 23x minus x multiplied by 2x plus 3 to be squared, but we just figured out that was this. So now I can write this instead. Okay, and this is 23x minus 4x cubed. So whenever you're multiplying and the numbers are the same, so in here we have x's multiplied by x's, you always add the powers. Okay, so that's where the x cubed has come out of. I said, okay, 1 plus 2 is 3, and therefore it's x cubed. Okay, and here we have an x squared, because x times x is x squared, and then I can just do minus x multiplied by 9 is just minus 9x. Now again, I have x's and x's, so I can add them. So I can get minus 4 x cubed minus 12x squared plus 23 minus 9 is plus 14x. And that's the final answer. Okay? And then another thing you can also do is something like 4x minus 5 cubed. So again, what is the definition of cubed? If I had a cubed, that's a multiplied by a multiplied by a. So I'm just going to write this as that. This is equal to 4x minus 5 multiplied by 4x minus 5 multiplied by 4x minus 5. So now, again, I'm just going to multiply these two things together first. So 4x multiplied by 4x is 16x squared. 4x multiplied by minus 5 is minus 20x. So again, just to be completely clear and transparent, it's this by this, this by this, this by this, and this by this. Okay? So that's where so 4x multiplied by 4x is 16x squared. 4x multiplied by minus 5 is minus 20x. Minus 5 multiplied by 4x is also minus 20x. And then minus 5 times minus 5 is plus 25. Again, because minus by minus is plus. And this is equal to 16x squared minus 40x plus 25. Okay? But that's also being multiplied by 4x minus 5. Okay? Again, I should have given myself a little bit more room. I must say that's the best thing about having an iPad. I can just move things when I make mistakes. Okay, when I don't have proper foresight. So, now, okay, not that. Alright, there we go. So, now, how do we do this? You're probably looking at that and saying, oh no, now there's another term There's 3, not 2. This is the thing about maths, and it's going to come up so often, okay? We are going to do the exact same thing as what we just did. There's no reason to change, okay? If maths works for a certain case, it needs to hold for all cases. That's what maths is, okay? So if you're sitting there and you're like, oh, I don't know what to do. Oh, well, if there was 2 numbers, what would you do? You'd say, oh, the first number multiplied by the 2 numbers, and then the second number multiplied by the 2 numbers. Okay, and what if there's a third number? Well, then what do you think you'll do with the third number? The exact same thing, okay? So what you're going to do is, I'm going to multiply this number by this number. I'm going to multiply this number by this number. I'm going to multiply this number by this number. I'm going to multiply this number by this number. And I'm going to multiply this number by this number and this number by that number. Okay, there's no reason for me to do anything else. There's no reason for me to switch my approaches. I'm just going to do the exact same thing as what I just did. Okay. So now, 16x squared multiplied by 4x. This is going to be 64. X cubed. 16 multiplied by minus 5 is going to be minus 80. X squared. Minus 40x multiplied by 4x is minus 160x squared. Minus 40 times minus 5 is only plus 200x. 25 times 40x is plus 100x. 25 times minus 5 is minus 125. Okay. And then again, I can group terms. So this term here, they both have x squareds. And then these terms here all have x's. Okay. Sorry, that's just annoying me. That a little bit of that is still white. Sorry. Okay. So now I can just group terms. So the only x cubed that's there is 64x cubed. So it's just 64x cubed. Now, these are both x squareds, which means I can add and minus them. So I can just do minus 80 minus 160 to get minus 240. Alright. Then I can do, because there we have just x's with the 200 and the 100, I can just add them to get 300. And then I'm just left with minus 125. Okay. So that's the answer for that one. Sorry, I probably should have boxed all my answers when I got them. But, oh well. Hopefully I'll be able to remember to do that for future. Okay, so that's that. I'll keep Pascal's triangle. I'll do Pascal's triangle as well in this video. Do a couple of examples and then, yeah, we'll go from there. So, Pascal's triangle, what is it? If you do a plus b to the power of 0 to the power of 1 on and on, what you get is, you get this. Okay? There's a certain pattern that goes with this. So now you're probably sitting there thinking, oh, well, okay, again, I should have left myself more room. So let's say it's not like I'm paying for paper, so I don't know if I am. So we can do Pascal's. C-A-S-C-A-L-S. There we go. So you might wonder, why is this a triangle? The reason is that you start your triangle off with the 1. all right? And then you move it down to 2 ones. So you always put ones on your diagonal, okay? So all the ones always go out. And so on and so on and so on. Now, how do you fill the middle of Pascal's triangle? You add the 2 that are above it. And just be careful, there should always be 1 element in the top one, 2 elements in the second row, 3 in the third, 4 in the fourth, and so on and so on. So here, in the first row we have 1, in the second row we have 2, perfect. In the third row we need 3, but I have only 2 things. I only have a 1 and a 1. So I need to do something with the middle. Some number needs to go into the middle. What is that number? That's going to be, if I add these 2 numbers together, I get 2. And you'll notice this is the same as this. Okay, just to be completely explicit, here we have 1a and 1b. Here we have 1a squared and 1b squared. Here we have a 1. Here we have 1s. I get a new highlighter. Make green. Green might be nice. So we have 1 there. We have a 2 here. And we have a 1 there. And this is precisely what we have here. And this keeps continuing indefinitely. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 5 plus 1 is 6. 5 plus 10 is 15. 20, 15, and 6. And on and on and on. Forever and ever and ever. Okay. This is what Pascal's triangle is. And so, you might say, well, how is this useful? The reason this is useful is that these are what we call the coefficients, okay? The coefficients of the expansion. Okay, so this is if it's to the power of 0. That's if it's to the power of 1, power 2, power 3, power 4, power 5, and power 6. So what this says is, if I asked you what a plus b to the power of 6 was, what is it? Well, the first number is a 1. That's 1, a to the power of 6, b to the power of 0. And notice, if you add these 2 things together, you always get 6, which is what it needs to be. Okay? The next number is a 6, so it's plus 6. It's going to be a to the power of 5, b to the power of 1. So again, 5 plus 1 is 6. It'll always add up to 6. The next one is 15, so it's plus 15. A to the power of 4, b to the power of 2. The next one is 20, so it's plus 20, a cubed, b cubed. Then it's going to be plus 15, a squared, b to the 4. Then it's going to be plus 6, a to the power 1, b to the power 5. And then it's plus 1, a to the power 0, b to the power 6, sorry. And NB. So NB just stands for something very important. A to the power 0 is always equal to 1. Basically the idea is that if you do a to the power 1 multiplied by a to the power 1, you get a to the power 2, so I add the powers. Therefore, if I do a to the power 1 divided by a to the power 1, I need to minus powers, so I need to get a to the power 0. But sure, a divided by a is just 1. And therefore a to the power 0 is always 1, so long as a is not 0. Okay? So, back up here, I can basically get rid of. I'll just do kind of in a weird color, but b to the power 0, you can basically just get rid of that and say, okay, that's 1. And the same thing here. You can just act as if that isn't there, that it's just, 1. So it's the same thing back up here with the 1a squared plus 2ab plus b squared. I didn't write a squared multiplied by b to the power of 0, because b to the power of 0 is just 1, and therefore there's no point in writing it. The same reason that I didn't write the ones. I know I wrote them in this case just to be completely explicit and completely transparent. But yeah, that's all Pascal's triangle is. If you just add. So once you remember that 1 goes along the side the whole time, then you get this, okay? And this always works, which is quite nice. So yeah, that's so if you were asked to do something, a bit crazy, you could, in theory, just do this instead. It's much simpler. It's not half as painful. Because so back here when we had the cubed one, like that took a lot of effort. Yeah. So what? But actually, just to end this video, I'll do that again just to show. So we should get the exact same answer. Okay. So if I do 4x to be cubed, okay. This is this one, okay? So my coefficients are 1, 3, 3, and 1. Okay, so this thing. So if we had a, so I know that a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. That's what it is. So now I'm just going to plug in a equals 4x and b equals minus 5. All right. So if I just plug them in, I just get that it's 4x cubed plus 4x squared multiplied by minus 5 plus 3 multiplied by 4x multiplied by minus 5 squared plus minus 5 cubed. So 4x cubed, 4 cubed is 64, x cubed is just x cubed. So here we have 1 minus, so it's just minus. If there's 2 minuses, it would be back to plus, but there's only 1 minus. 3 multiplied by 5 is 15. 5 multiplied by 4 squared, so 4 squared is 16. And 5 multiplied by 16 is 240. So it's minus 240 x squared. Minus 5 squared, that's 25. 25 multiplied by 4x is 100x. 100x multiplied by 3 is 300x. And then minus 5 cubed is minus 125. So you can see here an awful lot less effort went into it rather than doing this, So that is a lot more difficult, and yeah, because you can imagine here at this step, sorry, I get a pointer fairly soon, but at this step here, basically what you have is you end up with 3 terms, and you always will. 3 terms multiplied by 2 if you do cube it out. And you can imagine then if you go to 4 terms, so what if we did it to the power of 4? Then all of a sudden I'd have to do 3 terms and then 4 terms. And if I did it to the power of 5, I'd end up getting 4 terms and 5 terms. And then if I did it to the power of 6, I'd end up with 6 terms, and so on and so on. So here we have 3 multiplied by 2, whereas we would end up with having to multiply 3 terms by 2, and then 4 terms by 2, and then 5 terms by 2, and then 6 terms by 2. if we wanted to do it to the power of 6. All right. So it gets very painful very, very fast. And that's why it's so powerful just to learn this formula. You don't have to learn off at all. Just know how to get Pascal's triangle and what it is used for. All right. It'll just save you an awful lot of heartache in an exam if you're struggling for time, and you've only a couple minutes to solve the question. Like, you can just solve it really fast just by knowing Pascal's triangle and being able to draw a couple lines, add a couple things together, and then getting the coefficients and then just being able to plug them in, So yeah, I'll leave that for this video. In the next video, I'll go over a little bit more about it'll be factorizing. Yeah, the next video will be factorizing. So yeah, that's a nice note to end on. So yeah, thanks so much for watching, and hopefully I'll see you in the next video.